Hi, are you struggling with the increase in costs of getting a CDC stream out of Oracle? My name is Daniel Diov. I'm the community champion at Tabsdata, and today I wanted to show you how Tabsdata can help. All you need to do is connect your Oracle database, publish multiple versions of the same table into Tabsdata, and then build a Tabsdata function that will compare the new and older versions in order to build a CDC stream that you can then subscribe to any number of destinations. I'll be doing this today by running an Oracle database inside of a Docker container on my local machine. I will then have 4 Tabsdata functions that will be doing different parts of my workflow. My publisher, Oracle Pub, will grab data out of my Oracle database and load it into a Tabsdata table called customers. My Tabsdata transformer, called TRF-CDC, will grab the top-level commit to the customers table, as well as a snapshot of the customers table that is one commit behind. It will then compare these two versions of the customers table and build a CDC stream called customers CDC. Lastly, we will have 2 subscribers, one for Postgres and one for AWS Iceberg, that will grab the customers and customer CDC Tabsdata tables and load them into Postgres and Iceberg under the same table names. So, without further ado, let's hop into our code. I'll be interfacing with my Oracle database through an SQL worksheet. And then I also have my 4 Tabsdata functions listed here with my publisher, my transformer. I then have my 2 subscribers, one for AWS Iceberg, as well as a Postgres subscriber that takes these same 2 tables and loads it into Postgres under the same names. To start, I'm first going to initialize my customers table in Oracle. I'll do that by running my SQL script that will insert these 9 customers into that table. I can check their status by running the select query here to see that has been completed successfully. Next, we need to trigger our Oracle publisher. And because Tabsdata has automatic downstream dependency management, once we run this publisher, because Tabsdata will be able to see that the transformers and subscribers are downstream dependent to the publisher, those will run automatically. We can trigger our publisher by running td fn trigger with a couple of flags to denote the function we want to run, which is Oracle Pub. Whenever you run a Tabsdata function, Tabsdata automatically generates a workflow execution graph that shows every single function that runs downstream of the one you triggered. And so we're starting with our publisher that takes data from Oracle and loads it into a Tabsdata table called customers. We are then triggering our transformer that takes the top-level commit from customers, as well as a snapshot of customers that is one commit behind. It then compares those 2 snapshots and builds the table customers CDC, which is our CDC stream. And then we are then triggering our 2 subscribers, one to Postgres and one to AWS Iceberg, which then loads the customers table as well as the customer CDC tables into those respective databases. So now that a couple of seconds has passed, we can check our execution status by running td exec list-trxs. And so our workflow has successfully finished running, which means that we should have data in Postgres as well as in AWS. I can check by hopping into our Postgres instance first, where we'll see 2 tables, one customer CDC. Our customers table has 9 people, and customer CDC shows 9 insert operations. If I hop into S3, we now have some Parquet files for our customers and customer CDC tables. And if I query them in AWS Athena, we will see that same exact data that we saw in Postgres. And so looks like everything ran successfully. Next, I want to run a more complex use case of capturing our CDC stream. And I will do that by running 3 new operations on our Oracle customers table. I will do that by running this SQL script. When I run this, I will insert a new customer called Alice Smith. I will delete a customer whose SEQ value equals 4. And I will also update a customer so their age becomes their age plus 1. So I will run this now. And we can check the status of our operations by requerying the customers table to see that those updates have come through. So next, all we need to do is re-trigger our Oracle publisher in order to get the second version of our customers table, and it will automatically run all of our downstream transformers and subscribers. So I'll do that by running td fn trigger. Here's that same workflow execution graph, and we just have to wait a couple of seconds for this workflow to finish running before we can check the status of that execution. We can check that by running td exec list trxs. And it looks like that has published successfully. So now let's check Postgres and AWS. If I hop into Neon and we reload our schema, we can first check customers to see that we now have a 10th insert, we have a delete, and we have an update operation. Also, if I hop into the customers CDC table, I will now see 3 new rows, one for a delete, one for an insert, and one for an update operation. If I hop into Athena to check our Iceberg tables and I rerun the customers and customer CDC tables, I should also see those same changes reflected and those operations being captured within the customer's CDC table with those 3 new rows. And that is how you use Tabsdata to ingest a table from Oracle, build a CDC stream off of changes to that table, and then subscribe that CDC stream into AWS Iceberg as well as Postgres. If you have any questions about this tutorial or Tabsdata in general, please feel free to reach out on the Tabsdata Slack or Discord, where our team is happy to hop in and help. Thank you.